Hello, I'm Dr. Kristin Bibbins-Domingo, and I'm here to encourage physicians interested in all aspects of editing and publishing at a major medical journal to apply now for the Morris Fishbein Fellowship in Medical Editing. This is a unique one-year fellowship offered by JAMA to introduce physicians to all facets of editing and publishing in a major medical journal. The application deadline is January 5th, 2025, and for more information, including information on how to apply, please go to jamafishbeinfellowship.com.
From the JAMA Network, this is JAMA Author Interviews. Conversations with authors exploring the latest clinical research, reviews, and opinion featured in JAMA.
Hello, and welcome to our listeners around the world. I'm Dr. Kristin Walter, Deputy Editor at JAMA, and I'm joined here today by Dr. Juan Carlos Celedon, who is the Niels Jern Professor of Pediatrics in the Division of Pediatric Pulmonary Medicine at the UPMC Children's Hospital of Pittsburgh and University of Pittsburgh in Pennsylvania. Today we will be discussing a study that Dr. Celedon co-authored titled Transcriptomic Profiles in Nasal Epithelium and Asthma Endotypes in Youth. This article was published online in JAMA on January 2nd, 2025. Welcome, Dr. Celedon.
Thank you.
So asthma is a heterogeneous disease, and studies of gene expression and bronchial epithelium from adults have identified asthma endotypes called T2 high asthma and non-T2 high asthma, which are based on levels of T helper 2 cells and T helper 17 cells. Can you discuss the characteristic CD4 T-cell subtypes of T2 high asthma and non-T2 high asthma and their association with specific cytokines, IgE, and airway eosinophils?
Sure. So in general, T2 high asthma is characterized by high levels of IL-4, IL-5, and IL-13 cytokines, and clinically by high levels of total IgE and eosinophils. Whereas non-T2 high asthma, like T17 high, is characterized by high levels of IL-17 and IL-22 cytokines and high levels of neutrophils in the airways.
And which type of asthma is more common in adults, and which medications can be useful for these different types of asthma?
So to date, it's assumed that T2 high is the most common type of asthma in both kids and adults. And for severe T2 high asthma, now we have an armamentarium of monoclonal antibodies that can block different parts of the pathway for T2 high asthma. Some block anti-IgE, like omalizumab, and some others will block the IL-4 or IL-5 pathways. However, we do not have the same tools for T2 low asthma.
And what have previously published studies reported about asthma endotypes in children?
So unfortunately, because of the difficulty of doing bronchoscopies in children, most studies of endotypes have been done in adults. There was an attempt of characterizing T2 high and T2 low asthma using nasal epithelial expression in children. But in that study, the only genes that were characterized were those for the T2 high pathway. So they could only divide the participating children into T2 high and T2 low. In this study, we also use markers for T17 high asthma, so we could characterize 3 endotypes using nasal epithelial expression.
And the goal of your study was to identify asthma endotypes based on 3 studies of youth with asthma who were aged 6 to 20 years, most of whom were from racial or ethnic minorities. Can you describe the demographic characteristics of the children in these 3 studies?
So there were 3 studies. STAR was a study done in Puerto Rico and Pittsburgh, and the participants were Puerto Rican or Black or African American. In the other study, EVA-PR, all participants were Puerto Rican. And in the third study, BDKA, over half of the participants were Black or African American. Overall, most participants, but not all, were Puerto Rican or Black or African American.
Why is it important to study asthma in minoritized youth?
Because these are the two groups, Blacks or African Americans and Puerto Ricans, who are most heavily affected with asthma. They have the highest prevalence, morbidity, and mortality from asthma of all major ethnic groups in the U.S.
Can you describe what types of tissue samples were obtained from the youth in these studies, and how was this procedure performed?
Sure. We collected samples of nasal epithelium, and the way this is done, lidocaine 1% was sprayed. We took brushings and gentle curetting of the inferior turbinates on both nostrils of these children, and then we used these samples to extract RNA for studies of gene expression.
In addition to clinical characteristics, these 3 studies provided some additional laboratory data. Can you describe the specific blood tests and lung function testing that were available from these studies?
So in these studies, we collected total immunoglobulin E, IgE to a specific common allergens, those mite, cockroach, etc. We measure blood eosinophils. And also, in one of the studies, STAR, we collected a fractional exhaled nitric oxide, or FeNO, which is generally considered a measure of airway eosinophilia.
And there was also spirometry?
We also did a spirometry in all children, and with that we can measure lung function, forced expiratory volume in 1 second, forced vital capacity, or FVC, and the ratio of the two. And that way we can assess airflow obstruction. We also measure response to albuterol in all these studies.
And the primary outcome of your study was nasal epithelial transcription profiles of 3 T2 and 5 T17 pathway genes. Can you describe the main findings of your study?
So, as I've said, based predominantly on studies that equated atopy or any type of allergy, sensitization to at least one allergy, to T2 high asthma. T2 high asthma has been often considered the most common endotype in children. However, recent literature suggests, not using gene expression, but suggests that perhaps T2 low asthma is more common than previously thought. And that's what we found. So in all 3 studies, T2 high asthma, T2 low asthma, including T17 high and T2 low, T17 low asthma, was more common than T2 high asthma in these 3 studies of predominantly minoritized youth.
That leads to my next question. Were there any results in the study that were surprising to you?
Well, in some ways, yes, because of, again, this belief that T2 high asthma is the most common type of asthma. So even though we hypothesized that T2 low asthma would be more common, still, somehow surprising that was the case in all these 3 studies. One thing to mention is that most prior studies in adults are predominantly in white populations. So it's intriguing that in these minoritized youth with high asthma burden, T2 low asthma would be more common, which could have eventually therapeutic implications.
Can you outline a few limitations of your study?
So the first one is that really there is no gold standard for endotypes. We have tried to define these based on gene expression, which is what other groups have done. We believe they have some validity, but there may be other ways as the field evolves. The second one is that this study is cross-sectional. All 3 studies were cross-sectional. Therefore, you cannot establish temporal relationships. It is possible that endotypes change over time, or that endotypes change as a result of treatment, and that would have to be evaluated in observational studies. Finally, there could be some overlap between endotypes, and again, this can be assessed in future studies.
Do you have any future research planned on this topic?
So in one of these studies, we will have longitudinal data. In EVA-PR, which is one of the 3 studies, we are now repeating all these transcriptomic studies when the participants are 21 to 29 years of age. This would allow us to see how these endotypes evolve during adolescence and young adulthood. Particularly after puberty, we can examine, hopefully, the effects of sex hormones, etc. The second set of studies that are planned in the near future are looking to see where environmental exposures have differential estimated effects depending on endotype. That is, some environmental exposures may affect all endotypes equally, while others may have stronger effects in one type of asthma over the other.
Before closing, is there anything you'd like to mention that we haven't previously discussed?
I think it's also important to note that unlike most prior studies in this field, we ensured that the children were not treated on systemic corticosteroids. 96% did not receive nasal steroids. And most or all were not current smokers or former smokers with significant smoking history. And also they did not have self-report upper respiratory illnesses. All of those can confound these studies, and we accounted for all these factors. I think that's an important difference between our study and prior ones.
Thank you so much for sharing your thoughts with us about this interesting topic. I'm Dr. Kristin Walter, and I've been speaking with Dr. Juan Carlos Celedon. You can find a link to the article in this episode's description. To follow this and other JAMA Network podcasts, please visit us online at jamanetworkaudio.com or search for JAMA Network wherever you get your podcasts. This episode was produced by Shelley Steffens at the JAMA Network. Thanks for listening.
This content is protected by copyright by the American Medical Association with all rights reserved, including those for text and data mining, AI training, and similar technologies.